Hi, the big day has arrived. You're about to be interviewed for the job of your dreams, being an engineer in Stordo. You already know about objects, processes, states, the basics of OPM, and it's now time to show them what you know. Good luck!
Hello, it's good to see you and thank you for coming. We want to give you some feedback on the work that you have done.
We reviewed your answers to the question on the processes, object, and states. And it seems like you understand very well the basics of OPM.
As we told you in the first interview, we use OPM to model our system. Since OPM is recognized as ISO 19450, OPM allows us to work with global companies.
That's right. Also, it's very important for us that everyone in the company communicates well with all the others. That's why we model company procedures using OPM. It helps us to communicate and to identify issues for improvement. Your assignment is to create 3 initial models in OPM. The first is of our battery, the second of an electric car, and the third a model of driving an electric car.
OPM has its own dedicated cloud software called OpCloud. We use it to collaborate on construction, on system models, for research and development, and for manufacturing. We ask that you learn how to use OpCloud so you can use it to create the models we ask you to prepare.
This helps because OPM with its OpCloud implementation is not only graphical, it is also textual.
Okay, the interview went very well. Let's go over the assignment you just received. It's really not complicated. What we need now is to put together the pieces of the puzzle and learn about relations in OPM. In OPM, we model systems using things and links between things. Things can be processes or objects. And as we learned, objects can have states. Relations in OPM can be between an object and one or more objects, a process and one or more processes, or between objects and processes. The battery you were asked to model is, of course, an object. Let's watch together a video which describes the electric cell and its structure. This is Stordo's cell. It is shaped like a pouch that fits into a smartphone. Many cells comprise the electric car's battery. A cell is composed of various advanced materials which enable it to be charged in record speed. Each cell is one of many that comprise the battery inside the charging module. A pile made up of many charging modules is laid inside of the car chassis, and together they provide the car with the energy to move. The relation we have here is between the whole and its parts. The car chassis contains the pile of charging modules. Each pile is made up of many charging modules. Each charging module is composed of many pouch cells or batteries, and each battery consists of different materials. So, in the video we just saw, the car chassis can be called the whole, with the rest of the objects we listed, its parts. Processes can also have a whole-part relationship. For example, the process of operating the electric car is composed of sub-processes such as car starting, car driving, and car charging.
OPM has its own dedicated cloud software called OpCloud. We use it to collaborate on construction, on system models, for research and development, and for manufacturing. We ask that you learn how to use OpCloud so you can use it to create the models we ask you to prepare.
This is what OpCloud looks like. Here is the canvas, and here is where you can select what thing to add to the canvas, an object or a process. Let's model the video we just saw. First, we'll add the objects to the canvas: car chassis, charging module pile, charging module, and pouch cell. Of course, all these objects are physical, so they are shaded. This is the time to learn about a simple kind of link between objects, the aggregation participation link. The name of this link describes what it does. It connects between one object, which is the aggregate or the whole, and other objects, which are the participants or parts of the whole. An aggregation participation link does not link objects with processes. This means that in OPM, an object cannot be composed of processes. Similarly, processes cannot be composed of objects. Now, let's start connecting the objects. First, let's connect car chassis to charging module pile. An aggregation participation link is represented by a line with a black triangle along it. Great! Car chassis is now connected to charging module pile with an aggregation participation link. Let's connect the rest of the objects. We have a hierarchical structure of objects representing a whole-part relationship. Notice the sentences formed at the bottom of the screen. Car chassis consists of charging module pile consists of charging module, and so on. We will expand on the verbal part of OPM in the future. Excellent! As we mentioned, processes can also have a whole-part relationship. Here, too, we can represent the relation between a process, which is the whole, and processes that are its parts using an aggregation participation link. Let's start a fresh new model. We'll add to the canvas the processes we mentioned before: car operating, car igniting, car driving, and car charging. Notice we added to each process name its related object, car. This makes the names of the processes in our model clearer. These are all physical processes, so like the objects, they are shaded. Let's connect the car operating process to the other processes. Here, we also received a hierarchical structure, but unlike the model we created for objects, here the hierarchy is not complex. It is simply one process composed of three parts below it. Notice the sentence formed at the bottom of the screen. Car operating consists of car starting, car driving, and car charging. Come, Hopcat, please summarize for our friends the important things we have learned.
Aggregation participation, also known as whole part, is a structural relation in which the whole aggregates one or more parts.